RC with Adam is brought to you in part by these super awesome people. Hey everybody, welcome back to RC with Adam. My name is Adam, and today we're taking a look at the MiniHawk. I've slowly been chipping away at this, or printing away at this, for, oh gosh, like a long time, like 6 months or something, which is just my fault. It's not that complicated of a build, although it is a kind of complicated build. This is a 3D printed VTOL, vertical takeoff and landing aircraft designed by Steve Carlson. It's called the MiniHawk. And it comes in, or it doesn't come, but you print it in all of these different parts. I think I have everything or almost everything printed here. So in this video, I'm going to show you what I printed and what the printed parts look like, as well as go through some of the parts that you'll need, some of the electronics to that you'll need to purchase, and I've got some of these right here. Now, check the links in the description below for more information on the MiniHawk VTOL. You can find a link to GitHub, or I'll probably just link to the Hackaday page for this, which will get you all of the you can get to all of the STL files and everything that you need to build this. And what I'm going to try and do is actually put together a sort of a shopping list, or I'll put links where I got my components, the electronics and everything, so that it will hopefully be easier for you guys to track down all these different parts. Also, I think all of these parts are correct, all of the electronics components that I have, but I haven't actually built this thing yet, obviously, so I'm not totally sure that they're going to work just right. But these should be something close to what I need. Okay, first let's talk about the 3D printed parts. This is a wing section. I love the wing shape, very nicely designed. We have some pockets for servos. Now, first of all, let me just tell you, this stuff is actually printed in OBC from 3D Fuel. And this is like flexible, and it's not going to work. I think it's just too flexible. The hinges hinge great, which is cool, but I think this material is just too darn flexible. It's almost it's kind of like a sort of like a flexible nylon type of thing, but it's not going to work. And it didn't print out quite right, and it's sort of warped towards the bottom as well. So we're just going to kind of put that aside for now. But it was kind of a cool test to show how this material will print and how it could possibly be used for a wing. You see how I'm bending it. It will tear eventually, but it is pretty darn durable. And so that's what I like about this OBC material. I have a video about the OBC material if you want to check that out. I did print the actual nose, or I would kind of call it the fuselage, but I think it's actually called the nose section in OBC. And so it's very flexible, possibly too flexible, but we shall see. Mostly I'd be concerned sort of about this lid area coming apart. Because it can flex like that, but we'll see about that. I could probably reinforce that. The main thing that I was concerned about for this is that I want this section to be very durable, because I'm thinking it seems quite likely that it would break right around here in this kind of nose forward section. So I wanted to make sure that was very durable, and in this case it will bend rather than break. So that could be a problem, but we'll see. I may need to reprint this. All right, here's another wing that I printed. Now this should work. This is a, well, it's clear, which is super cool. This is in the 3D Fuel Workday PLA, and it's basically kind of like PLA Plus. It's like their mid-grade PLA, and this looks super cool, especially if I put some LEDs in here. It should look really awesome. It's kind of actually hard to see the definitions of the definition in the different points. I don't think this printed out quite perfectly, but I think it's good enough for a first effort to see if it actually works. So this should look really cool. And then here's this wing that I printed most recently. I printed this in 3D Fuel Workday or Pro PLA. I think this wing turned out quite nicely. As you can see, it's a nice black color, stealth black. And then we have the actual control surface running along here. And we have some cutouts. We have a cutout here for the control horn. And you see here we have actually cutouts designed for hinges. I actually did not get the hinges, but you could install hinges, plastic hinges right here, here, and here, which is very thoughtful in the design. And then we have cutouts for the servos, or not cutouts, but you know, we have little spots for the servos, for the control surface, and then a servo for the actual motor controlling the tilt of the motor. And what's cool is that hopefully this like printed out okay, but there's actually Steve actually designed, you can't see it in here, Steve actually designed little little channels in the wing. You can kind of see it in this wing, maybe a little bit. You can kind of see these sections here, so these little tubes that allow you to route the servo wires and the wires for the motors through here. So hopefully those printed properly. As you have seen in the photos, because I'm sure I showed you some photos of what this is actually supposed to look like. Here's what mine is going to look like roughly with the major pieces together. So we should have a nice clear wing on one side and then black on the other, and it should look super awesome. So that'll be great. So we have our two wings. And these are identical, but they are mirrored. It's just the same STL file for the wings, but then you just mirror them in Cura. And pretty much the same goes for a lot of the other components as well. Here we have the other pieces, and again, I think I printed out everything. There might be some other parts that I'll need to print out or reprint or something like that. But we have these little fins, and I think these might need to be made larger, because I believe these are the original size. And Steve was saying that he had better performance with a little bit larger vertical stabilizers. But we have those. We have these guys, which these little thin stabilizers, which go, I believe, on the bottom. Again, I haven't actually made one of these yet, so I think I know how everything goes on here, but not totally sure. Here we have the inner the little support tracks for the battery and for the flight controller. Drop in there and then get screwed in place. So that's very cool. Adds some rigidity and a good place to mount the battery and all the inside electronics. Here we have the, what is this? I guess this is like the empennage, and this is the rear motor mount. So the back motor is going to sit right in here. And these two pieces, of course, are going to get glued together. And then this section right here is going to get cut out, as well as this section here. That is my understanding. So it's just one layer, so we can pretty easily cut that out of there. And then these will get glued together, and then these go on the back of the nose section. This is the original canopy cover that I have here. This was a little tricky to print, and again, sorry that you can't see the definition super well with this clear PLA, but you see I did have some problems with just some like overhanging PLA just sort of falling down here, so it wasn't, I guess I'd have to add support material in, but I didn't really want to add support material because there'd be just a lot of support material. But I may need to do that in order to get a good print out of it, because it does print upright in this orientation. In any case, these are the canopy covers, so they will basically snap in place here or something like this. But like I said, these are the older style that Steve designed, so this one does not obviously have a mount for the camera, which I think it looks really good. Super like sleek looking. It looks really great. Again, my concern would be that these might pop out since the actual body is flexible. So what I might have to do, or at least for the tests, my first test, I might just need to like tape this in place or or maybe screw it in place or something. I'm not really, probably not screw it in place, but somehow hold this down securely. And then let's see here, where'd it go? Okay. And then this is the newer version of the canopy cover, and this one has, actually I'm not sure what these are for. I don't remember what these little spots for screws are for, but or what's supposed to be mounted there. But this one has the little mount for the camera, for the FPV camera, and so this would go. I haven't printed the other side. I need to print the other side for this one, but that would go on the top like that, and again snap into place like so. So you can kind of see the difference there. How that how the new one with the camera mount sticks up like that. So that should look cool though, and especially with this clear canopy. Oh, if I could put, well, there will be some LEDs in here just from the electronics, but yeah, putting like, if I could make this glow like blue or red or just any color, that would be super sweet. By the way, these guys right here, these fins, you don't actually need 4 of them. I just printed 4 because this one didn't turn out super great. Yeah, it kind of broke off there. But these other ones turned out okay. So I just kind of printed extras. And actually this one I printed, I think, with the wrong parameter, with the wrong Cura settings, because this one is like extra strong, which I kind of like, but that means more weight. Whereas this one is much more clear actually, but you know, not quite as durable perhaps. Anywho, so that's all that stuff. Now, here we have the, I can't remember which side. I think I think the black goes on the black side. Now here we have the actual motor mounts, or like the tilt mount. So this would be the actual motor mount. This is what gets mounted in here. And that kind of goes in here like so. And these are left and right specific, so you need to mirror this in Cura and print out left and right versions. And it goes in here something like this. Of course, you have to take out the support material, and then it tilts. If I can get this right. Yeah, so I need to file down a lot of this material so that it's flush and smooth. So the fit is not very good right now, but basically it's going to fit in there like that. And then there's a pin that goes through the top. And then you can tilt this to tilt the motor. And somewhere right here is where a little ball joint connection goes, which seems kind of super tiny. So we'll see how that goes. I guess it's working out for Steve. I think he's like the only one that actually has a working version of this right now. So we'll see how that holds up. But this whole thing goes on here, and it sits into this nice little, nice little, what would you call this? Well, this nice little spot that's designed for the mount. And this is how it looks on the bottom side. So that will just go in place like that. So there should be a pretty good firm connection once we glue it. You know, pretty good amount of surface area for sure. And you can see in here there's room. There's this hollow section for the motor wires to go through, and then they continue on through here, and then they come out right here. Just to see if this works, as an example, let's run this wire, which is a kind of a large wire, but let's see if we can run it through here. Oh, it works. Super cool. So you can run the motor wires through here and to the ESCs and all the rest of that stuff. Let's see, can we do the same? This might be too large, but let's see if we can do the same with these guys. Oh, it's working. Oh, look at that. That is so cool. That is very cool, because it makes a very, very clean wing, which I think is just great. Here's the clear wing. Let's test out these little tubes. Okay, cool. So cool. So you can actually see the wires. So that should be really cool when we build it. So it has this little channel for the motor wires coming out of here. And then this servo, the motor servo, we'll call it. Oh, did it print okay? See, that's the problem. If it didn't print well, then it might not work. Maybe we have to go from the other direction. So going from, well, that one works. The print kind of failed on this one. Oh, shoot. See, we're busting. Ooh. Yeah, we kind of busted through one of those little sections. So that'll be tricky. That'll be a little tricky to get that guy in there. Oh, one more thing I want to mention about the wing that is cool with the internal routing tubes for the lighting. On the wingtips here, we have a little spot where you could put like little LEDs right on the wingtip. And there is an internal tube, if it prints properly, to route a wire from the main body through here and then all the way out to here. And I'm just using solder wire to simulate actual wire, and it is a little tricky to get it through here. You do kind of need some wire that allows you to sort of push on it. And again, it has to print properly, but I think that is pretty cool. So you can see it pass through that little section right there where kind of all the wires kind of route from, and it runs through there. So pretty darn cool. Let's talk about the motors for this guy. Now, as Steve mentions in the instructions for the MiniHawk, currently the actual motor mount is designed specifically for the DYS BE 1806 2200, I think it's 2300 kV motor. And so I thought I had some of those that would work, but I actually don't, it turns out. But I do have this Emax MT 1806 2280 kV motor, and this actually fits pretty well with the diameter, at least. So let's get a closer shot of that. There we go. So this actually fits pretty well, but you'll see the problem is that the propeller would be way below this this shroud. So probably the easiest fix for that would be to either print out a separate spacer or just modify the design of this shroud so that you essentially make the motor about 3/4 inch, maybe a 1/2 inch taller than it normally would be. So you can kind of see that with this clear version, how low it would normally sit, and that is too low for the propeller to clear. So it would have to be about up there-ish. So it would have to be above this little dip cutout in sort of the lowest part of the actual motor mount shroud. And so he's thinking of updating this design to possibly just allow for larger motors like the 22 something series, in this case a 2205. And so this one, so what you would do is you would have two of these 1806 motors that fit in this shroud, and then and those would go on the front, and then you would have one 2205 or 2220 something motor, and in this case this one happens to be like an old Eachine MN 2205 2300 kV motor, basically generic quadcopter motor. And that is going to sit right in there. And another cool thing that he did is this internal routing on either side of the tail boom. I'm going to call this the tail boom. I think it's the empennage, something like that. But you can see here again with this clear version that we can route the motor wires through here, which is just really cool, and it just makes a really slick build, I think. And so your motor wires will need to reach all the way up into here. That's just what I wanted to mention about the motors. Make sure you have the right motors. And I'll probably use these just to test out and see if they work. These Emax MT 1806 2280 kV motors. And maybe I will print a spacer or something like that. Or I don't know. Maybe I will, maybe I won't. We'll see. We'll see about that. Let's move on to the other components here. Again, links in the description and to like the whole component list, and I'll try and put links in there, or I'll do something to try and make it easier for you guys to find these components. And I may forget stuff or leave something out, so just check the description for those links. So the first thing we have is the Maytech Systems FC F722 Wing flight controller here. And it has to be this one because we need to have the right, it needs to be able to use 4 servos and 3 motors. So that is, I actually have not used this before, so that'll be interesting, learning how to use this. I actually have not done any flying wings that use a flight controller before, so this whole thing is kind of new to me, but it's exciting to learn about that and stuff. Let's just open this up and take a quick look at this. Here's the Maytech Systems F722 Wing flight controller right here. Well, flight controller and power distribution board. ESC pads, LiPo pads, all kinds of pins and all this stuff. I'm going to say here, basically through Betaflight magic that Steve has come up with, we're going to be able to run 3 motors and 4 servos off of this, even though in the like in the sort of description of this flight controller it says that it can do up to like 3 servos or something like that, but we're just going to kind of ignore that. And here we have our 3 ESCs necessary for this, for each motor, one for each motor. These are Speedex ES20 Lite 2 to 4 cell 20 amp ESCs as per Steve's recommendation. And so we have the signal wires and the input wires, and then where we soldered the motor pads. So these are nice and small, nice and lightweight. They should work quite nicely. These ones say BL Heli S. Servos. So I ended up buying 2 different types of servos just to sort of see the difference. So we have these 2 different Emax servos right here, and I bought 2 of each. And one has a little bit higher torque than the other. And I thought these were different speeds, but I guess they're the same speed, I think. But you can kind of see the difference of them physically right here. So one is kind of taller and narrower, and the other one, or thinner, and the other one is a little bit thicker and shorter. But these should all fit just fine right in here. So this is where they would, where'd they go? So the servos would fit in right here. So as you can see, both of these servos will fit, and they should fit quite a wide variety of servos, but both of these will fit in here. The biggest thing, is my understanding, the biggest point about the servos is you want to make sure that you have Metal Gear servos, especially for the motor servos, the ones that actually control the tilt of the motor, because they are going to be working a lot harder. At least I think that's correct. Maybe it's the back ones. In any case, I got Metal Gear servos for all of the servos, so we'll see how these work out, and I'll let you guys know if these fail or if they work out pretty well. Now on to some of the Dubro sort of servo control-y airplane-y type parts. These ones are kind of hard to find, a little bit hard to find. These are the micro ball link. Okay, actually, I messed up here. You don't want this particular micro ball link. This one is too small, and it seemed really small, and I should have known. But it's actually a different one. It's actually this one that you want. I think this one will work. This is a 1/16 inch threaded ball link, as per the components list from Steve. And this one, though, has threads for the 2-56 threaded rod up to 0.072 inches. So I must have gotten confused because there are some other similar options. And this is SKU or model number or product number or whatever it is, 190. So look for Dubro 190. The Great Plains item GPMQ3843 is listed on the components list, but it looks like those are out of stock almost everywhere or discontinued. So I'm pretty sure that the Dubro 190 is what you want, and that is the threaded ball link, and that is a 1/16 inch thread size for that actual ball connection there, and I'm not sure what the actual ball size is though, but that's what you want. Also, I am going to get some of these guys. These are like the easy connectors. These should work. These say that they will work up to 0.078 inch rods, so this should work well for attaching the rods to the servos. And so that way it should be a lot easier to adjust them. So yeah, just check the description down below for the correct items, and let's continue. In any case, it's going to be something like this. It's going to be something like a ball link kind of socket situation. Okay, cool. And that's for the motors, to actually control the tilt of the motors. And then we have these guys. I went with the nylon version, the mini nylon quick link with 12-inch 256 rod. You can control the ailerons from the servo, so you would attach this to the, or I guess either end or whichever. So you could attach these guys and control the control surface. Well, there you go, folks. Hopefully this was helpful to you if you are thinking of building one of your very own MiniHawk VTOL 3D printed tri-motor aircraft. And mostly I just wanted to let you guys know that this is now publicly available, so you can download these files and print this aircraft yourself and buy the components and put this thing together. Be sure to hit that subscribe button if you want to see me eventually fly this thing when I get it put together, and I'll try to bring you along through that process. This has taken me a while, but now that I have all the parts together, maybe we can get started on this and get this thing up in the air. Be sure to check the links down in the description below for more detailed information on this. If you have questions about this, leave me a comment here or on the Hackaday page, and I will see you again very soon.